Stem and leaf displays are ways to quickly organize the data values that we've been given so that we can at a glance see what the data responses are and easily spot repetitions in the data. What you can see currently on the screen is an example of a stem and leaf display. Let's explain how we would read this. In a stem and leaf display, the digit to the left of the vertical line tells us the first digit of the number. So what I've highlighted here in blue is 1. That's telling me that everything in this row has a first digit of a 1. So the way I would read this is that this first item is a 1, 5, or 15. As I have another 5 coming after it, that means that there's a 15 that is repeated. And finally, the last digit on this row, the 8, means that I have a 1, 8, or 18. So this is the information that's encoded in our second row of the stem and leaf display, that our data have the values 15, 15, and 18. We can continue this with the rest of the values. So let's now look at the row starting with 2. In the row that starts with 2, this tells me that I have a 2 followed by a 0. That's representing the number 20. Next, we see we have a 2 followed by a 9. That's 29. Now that we've seen these first two examples, can you translate what the fourth row, the one starting with the 3, represents? That would be 36 followed by 37. Next, we have the row starting with a 4. It's telling us that we have the data points 42, 43, and 43 again. Now, you might be wondering, what about the top row? I intentionally skipped it so that we could first go over the pattern on values that are more clearly seen as 2-digit numbers. The first row is a little strange because what we want to gather here are actually all the numbers less than 10. So what is its, if we consider those as in the pattern of the 2-digit numbers, you would pretend there's a 0 in front of them. So this first row is communicating that we have a 1, a 2, and a 3. So these are the data items that were originally gathered from our survey, and to the left we can see them displayed in a stem and leaf display. Let's practice another example using stem and leaf displays. We recall the data given from our previous example where we had the hours spent studying. We had these 30 data points, and let's organize these using the stem and leaf display. So we always begin by saying, how many digits are there less than 10? Let's select those. And to represent those digits less than 10, we start with a 0 in our stem and leaf display, and let's list them from smallest to greatest. So we see 3, comma, I believe 4 is next, comma, 5, comma, 7, comma, and now we see 2 8s. I would want to copy it twice to show that there's repetition. And finally, 9. Now let's just glance over the 3 rows and make sure we didn't miss any data values less than 10. Okay, I think that's all. Next, let's look for the data values that are between 10 and less than 20. In other words, let's look for the data values that start with a 1. Let's record these values in our stem and leaf plot. So we record the values that are 2 digits that start with a 1. And let's try to record them in order. So looking at our orange ones, we see the lowest there is a 10, so I write 1 0, comma. The next lowest entry, I believe, is this 11, 1 1, comma. We have two 12s, so I'll record the 2 twice. Then a 13. Then two 14s. Record the 4 twice. Two 16s. And finally, an 18. Next, in our stem and leaf display, let's record those data values that are 2 digits and start with a 2. So those 2-digit numbers that start with a 2, in order, the lowest one we have is a 20, so we record 20, comma. Next, I think we have 22, and we're recording its second digit. Then we have two 24, so we'll record the second digit of 4 on the 2 row. Then a 25, a 26, and finally a 27. Next, let's include those 2-digit numbers that start with a 3. We have two 31s, so we record the 1 in the 3 row twice. Then we have a 33, and then we have a 35. Next up, let's include those 2-digit numbers that start with a 4. We see that those are 42 and 40, so as we label those, we will get 40 and 42. So this is our stem and leaf display organized from the 30 data entries we see above. So to practice working with the stem and leaf display, can you find the number 25 in the stem and leaf display? Visualize where that would be on the screen. The 25 is found in the row that starts with a 2, and then it is seen 5 places over on the digit 5, so 25. Our next few examples have us looking at bar graphs and line graphs and circle graphs. And as we look at graphs and answer problems about them, I encourage you to always spend a few seconds to familiarize yourself with the graph, and in particular look at how the units are labeled in the horizontal and vertical axes. For this graph, the vertical axis is measuring the U.S. antibiotic use. In different categories, we see that we have crops, pets, aquaculture, humans, and livestock. The horizontal axis measures the estimated annual use, and one thing that we want to note here is it did specifically say all these numbers are in 1,000 kilograms. So for instance, this 70 is not the number 70 as we think of, it's actually representing 70,000 kilograms. So our first question asks us, what is the total antibiotic use? And to answer this, we would just take each of the individual categories amount and then add those all together. Add these in our calculator and we'll get 17,200,000 kilograms. Next, we are asked about what percentage was used in livestock production. Now, if you're ever asked to find the percentage that occurs, remember this formula. The percentage can be found by taking the part, dividing it by the whole, and then multiplying it by 100. So in our case, the part that's used for livestock we can see is 13,540,000 kilograms. So our part is 13,540. Our whole is the number we just found above, 17,200,000 kilograms. We're going to divide those two and multiply by 100 in our calculator. And let's round that to 2 decimal places. Now we multiply that by 100. And we get, rounding to 2 decimal places, about 78.72% of antibiotics in 2013 were used in livestock production. The following graph describes the antibiotic resistance of Salmonella infections in humans. I would encourage you to take a moment and pause the video so that you can read over this graph and make sense of the different axes and what is being measured. Take a moment to pause and do that now. We see that the resistance to ceftriaxone is graphed in blue, and the resistance to ciprofloxacin is graphed in green. We look through the horizontal axes and we see it's measuring the years that pass between 1996, and as we read this, we see that each dash mark covers a distance of 2 years, from 1996 to 1998, from 1998 to 2000, and so forth. So, as we look over here, we see our final year is 2010, but there's one dash mark that occurs after 2010. What year would that represent based on the pattern set earlier on our horizontal axes? That would represent 2012, 2 years later. Now let's look at our vertical axes. We see it is measuring the percent resistant, and we have values between 0 and 5. Now that we've familiarized ourselves with this graph and what it's representing, let's see how we can answer the questions. What time frame is reflected in the figure? Well, we can see it starts at the lowest value of 1996 and goes to 2012. Our next question is, in what years were resistance to ciprofloxacin? Remember that ciprofloxacin resistance is in green, greater than resistance to ceftriaxone, which is graphed in blue. So we want to know, where is the green graph higher resistance than the blue graph? Let's look. Would y'all agree that in these portions of the graph that I highlighted, the green graph is above the blue graph? Now we just need to try to figure out, we've located